I hope you can hear me well.
We can hear
My
you.
screen, perfect.
Hopefully, you'll be able to see your screen as soon as you start sharing. Yes.
Okay, good.
Uh,
So, I'm going to present the 6Green project, which has Costas already said, I'm the technical manager. So, the context from which this project stems is that of the 6G and the expected power consumption. So the fact that these technologies are moving to a edge cloud continuum from 5 to 6G, it's going to be more and more relevant. It means that the computing resources will increase, and as a result, so will operating and capital expenses, and as a consequence, the carbon footprints and the energy requirements of these technologies. So in this context, the main objective of the 6Green project will be the promotion of energy efficiency across the whole 5-6G value chain. And the final goal is to enable all the technologies, so from the infrastructure up to the vertical application, to contribute to the reduction of the ecosystem carbon footprint by a factor of 10 or more. So the way that we plan to achieve this ambitious goal is to exploit and extend the current state-of-the-art cloud-native technologies, and in particular the SBA, by introducing new cross-domain enablers to boost the flexibility, scalability, and sustainability of the whole ecosystem, and enable all the stakeholders to reduce their footprint by making them cooperate towards a win-win green economy business. When we talk about 5-6G stakeholders, we mean mainly the infrastructure at the bottom, the network platform provider, and the vertical application provider. We what we consider when we talk about the enablers are three main groundbreaking innovations that we want to introduce in the project. The first one you can see already highlighted with a yellow arrow is edge agility. We got green elasticity and energy aware back pressures. And this is what I'm going to um, elaborate on in the next slides. So the first innovation that we want to introduce is edge agility, which is, so to say, a sort of handover mechanism for the SBA and the applications. So the idea is to make a sort of horizontal scaling in order to redistribute the workload according to the events driven by the user or the infrastructure, which means either a typical handover, so the user is moving and the application and network functions move along with him, or maybe resources are available in one micro data center, and they can be served with renewable energies, just to make an example. And the idea is that these kind of technologies will contribute to scaling the footprint of the slices and the vertical applications when they're not used. As a counterpart of this technology, what we call green elasticity is if edge agility was a form of horizontal scaling, green elasticity is a sort of vertical scaling. In a double sense, on the one hand, we expect these technologies to rely on hardware accelerators when and where available to maybe offload some of the processing to these engines when it could be convenient from the performance and or energy point of view. But also the idea is that of distributing the latency budget of verticals across the domains in a way that can holistically optimize the trade-off between the energy footprint and the performance of these applications. Finally, the energy aware back pressure is what puts together the three stakeholders that I mentioned beforehand in a way that provides a set of cross-domain observability mechanism and analytics that can describe how a vertical application, a slice, or the network induces consumption onto the actual physical infrastructure. So by providing this awareness and making this information pervasive across the whole ecosystem, uh, we want to pair this with with a set of incentives that can promote more virtuous behaviors at the higher levels. So where the impact of the power consumption is not economically perceived. So with how to say, a set of business models that keep the energy consumption into account, we want to motivate all the players to contribute to the overall energy and carbon saving. The structure of the project, the way we have designed it, allows to have these actions, so introduce these mechanisms and these policies through all the stakeholders. And the innovations pervade the three levels, as you can see in the arrows that go from top to the bottom, in a way that allows the cooperation that we want to promote in the project. So I'm going very quickly through the three research axes. So the first one is about the green enabling technologies for the cloud native services, and this is what the target here is the infrastructure owner. So the idea is the optimization of the actual execution environments of the microservices and the introduction of observability mechanisms in a way that allows to map the applications to the physical and initially to the container, and then from the container to the physical components that they rely on to allow the proper mapping of the power consumption that is ascribable to a virtual resource. The second research axis relates to the service-based architecture. So this is what we aim to investigate at the network platform level, with the evolution of the actual SBA towards the three innovations that we promote in the project. And this evolution involves both the individual functions of the 5 and beyond G core, and also the way they interact and they exchange information among themselves. So the idea is to map some KPIs that keep into account the energy consumed and deliver it on north and to the south. Finally, the third research axis is the one that mostly involves the concept of energy-aware back pressure. And the goal of this research axis is that of showcasing the benefits that can be obtained by approaching energy efficiency in a from a business model standpoint. So in a way that can give a win-win approach to all the players involved. So everyone can benefit from this model. Of course, this means hugely relying on the monitoring and the delivery of the monitored data, and using these data as KPIs for the economic incentives, clearly, but also to drive the life cycle management of the applications and of the network functions that are used to make them available. In this project, we have identified 3 use cases, and the reason for the reason why we've chosen exactly these use cases is to um, have examples of heterogeneous performance and operational requirements that can show how the project can give benefit to diverse uh, needs, so to say. So the first one is critical operation maintenance during energy constrained disaster scenarios. So it's about an evaluation uh, of the consequences of a disaster. So for example, in earthquake or something like that. So the infrastructure has been damaged. And in this case, we need applications that can work with low energy because this is what is available at the moment. The second use case is about energy efficient augmented reality remote assistance system. So in a context of a remote virtual visual assistance tool, we want to provide assistance in a remote fashion, but that still allows for carbon neutrality, so it doesn't have a huge overhead of energy. And finally, the zero carbon clientless virtual enterprise desktop as a service is something that we've all been very close to during the pandemic. So the idea is to provide systems that can shift most of the tasks from the clients to centralized servers, because these are what allow a better energy management. Okay, just to close my presentation, a little snippet of the way that the 6Green project is organized. We've got 15 partners from, if I can count correctly, 8 different countries. And we're particularly proud of having 4 telecom providers in our consortium. We believe that this will bring us to very fruitful solutions and hopefully also the delivery of these solutions. As I said, I'm the technical manager, and the coordinator is Professor Roberto Bruschi, which couldn't attend today, so has my presence. And I just broke the 12-minute barrier, as I can see, so I stop here, and we will talk again during the Q&A if you have any questions. Thank you.